Okay, so I finally got this calculator to work. Hopefully it will continue this whole time that we're looking at this. Example 2, use the calculator to evaluate its function. I'm not going to go back to the screen even though this says found. You should round your answers to 4 decimal places. The first thing, part A, it says cosine of 23.56 degrees. So if you look at your calculator, if you go to mode and it's in radians, you need to move it to degrees. Okay, so we'll go down, move it to degrees, hit enter, and you're good to go. Now I'm in degrees, I can get out of there, and I can actually just do cosine of 23.56. I don't have to put the degree symbol on there because I know I'm already in degrees, and I get that for an answer. I'm not, again, going to write it on there because I am a little hesitant about using this calculator because it's reset so many times. Part B, the tangent of 11 degrees, 19 minutes, 54 seconds. So the tangent of 11 degrees. So degrees was under angle. And then 19 minutes. Again, minutes under angle. And 54 seconds. Seconds is way down here by memory. And I'm still in degrees, so I want this to be in degrees, so I get an answer of 0.20. And so I ended up using the calculator to find those two things. Okay. It has to be in degrees. If it's not in degrees on your calculator, then you're going to end up getting the incorrect answer. Example 3, we'll get rid of that now. Example 3, find the values of theta in degrees and radians given theta is in the first quadrant. This is kind of a review going back to our unit circle. So let's go back to the unit circle, but we're looking at tangent being equal to the square root of 3 in the first quadrant. So the first thing that you need to be able to do on this unit circle is identify those quadrants again. Okay, we already talked about this, but just in case you don't have it, here's quadrant number 1, here's quadrant number 2, here's quadrant number 3, and here's quadrant number 4. Okay, you have to be able to identify those quadrants. So we're looking for tangent to be the square root of 3. Well, if you went through and you put the tangents around the outside, then you already have this done. Okay, but I'm looking in quadrant 1, I have really 3 different options for what could end up giving me a square root of 3. And one of them doesn't even make sense because one has square root of 2 over 2, square root of 2 over 2. There are no square roots of 3 in there. So it's going to be next to impossible for us to make a square root of 2 into a square root of 3 by finding a tangent of it. And so we'll just start by going taking the tangent. So we've got that this ordered pair is cosine comma sine, and tangent is sine over cosine. So I want to do 1/2 divided by the square root of 3 over 2. And we did this already, but we'll kind of walk through it again. If I write this way, as dividing, then I'm hoping that some of you already see what's going to happen, that you have to flip and multiply. And then the 2's cancel out, and I get 1 over the square root of 3. But I can't leave it that way, so I have to rationalize the denominator, and we did this work already. So I get the square root of 3, and then over the square root of 9, which is 3. So I get the square root of 3 over 3. Well, that looks pretty nice, but that's not what we're looking for. We were looking for a tangent being just the square root of 3. And so I really have only one other option here, but we'll go ahead and show that's true. So the tangent would be the square root of 3 over 2, and then divided by 1/2. If I take it and write it this way, you again realize that I want to flip and multiply. The 2's are going to cancel each other, and I get the square root of 3 over 1, which is the square root of 3. So this is the angle that I want to use that gives me a tangent of square root of 3. And so when I'm looking at this, I'm using the unit circle, pulling things off the unit circle. I want to use 60 degrees and pi over 3. So when I go back to what the question asked me here, it said find the values of theta in degrees and radians, given that theta is in the first quadrant where tangent is square root of 3. Well, the degrees was 60 degrees, and the radians was pi over 3. Okay, just pulling that stuff off of there. B, I'm looking for cosine equal to 1/2. So I go back here, and although it's in here kind of muddily, I'm looking at cosine comma sine, and I'm looking for the one that's 1/2. Well, the cosine is the x value, so I've got square root of 3 over 2, then I've got square root of 2 over 2, and I've got 1/2. Well, it's the same exact angle, except this time I'm looking at the cosine instead of the tangent. So the cosine of 1/2, cosine of theta equal to 1/2 is when theta is equal to 60 degrees or pi over 3 radians. And so what I just want to show you is that you can use the tangent or you can use the cosine of these angles, and you still end up with different positions. You can, if this calculator is still working, which I'm hoping, but out of luck, if you plug them into your calculator, if you did tangent of 60 degrees, you would get a number that's equivalent to the square root of 3. If you did cosine of 60 degrees, you should get 1/2 back. Okay, so use those. Use your calculator to prove that information. Otherwise, you can just trust that I gave you the right information from the unit circle.